This video is on relations versus functions. We've talked about how to tell if a relation is a function in words and on a graph. We've looked at examples of functions and examples of non-functions. Now I'm going to turn to the back. We're going to think about the set of coordinates 1, 2, 3, 4, 2, 7, 3, 4. Why is this a function, but the set of coordinates 2, 4, 1, 4, and 2, 6 is not? So this is the example that I took from the examples of a non-function, but I wrote this set as a function. So why is it that these four coordinates are a function, but this one is not? So if we look at our values, this first one has a repeating x value of 3, and this set has a repeating x value of 2. So why is it that this first one is a function, but the second one is not? So if we remember, to determine if it's a function, no repeating x values, unless the y values also repeat. So let's think about this in words. The x value of 3 repeats, but if we look at the y values with it, those y values also repeat. That is what we have to look at. If the x's repeat, that does not automatically say no. We have to look at those y values specifically. If those repeat, it is a function. So we can say, but the y value for both x equals 3 is 4. So what does that mean? They're technically the same coordinate. So I'm going to put therefore it is the same coordinate. So since it's the same coordinate, a vertical line would only pass through that one coordinate one time. So a vertical line will only pass through that coordinate once. But if we look at the second example, the x value of 2, as we remember, those repeat. So we look specifically at those y values. They do not have the same y value. So these are two completely different coordinates. I have at 2, 4 and 2, 6. So a vertical line would cross at two different points there. This is why this is not a function. Since this is the same coordinate, would I even have to graph it twice? It's the same coordinate. If you have the exact same coordinate, you only have to graph it once. So you can also, quote unquote, eliminate the repeating coordinate since it will already be graphed. We would not be able to eliminate any of these three coordinates because they are 100% completely different. 2, 4 and 2, 6 are located on two completely different parts of the graph. This graph is 2 spaces above 2, 4. So yes, they are completely different coordinates. On the first example, 3, 4 and 3, 4 are in the exact same location, so it will just make the dot darker. But again, you don't have to re-graph this one since we already have it graphed. So if I were to eliminate this coordinate right there because it's been repeated, the entire coordinate's been repeated, I can then look at my x values and I can see that all of those x values are now different, which makes it a function. Because this coordinate can be eliminated because it's already been graphed. So if I completely eliminate it, I'm left with 1, 3, and 2. Which are all completely different x values. So it is a function.